Hi class. So today we're going to do an analysis of variance using data that was uploaded to Canvas. And what I was interested in doing was looking at data that I downloaded on the LA County Department of Public Health website that's looking at coronavirus data. So I included a link on the PowerPoint, but it's this website. And then when I scroll to the bottom of the page, there's this table that's called LA County settings with 5 or more lab confirmed or symptomatic persons with at least one lab confirmed case. So pretty much they're looking at outbreaks of coronavirus. And in the table above there's a lot of outbreaks going on at nursing homes or skilled nursing homes. But I wanted to focus on, I thought it'd be more interesting for the class to focus on non-residential settings. And the list is much shorter. So what I posted online was actually downloaded May 15th. So today there's a lot less, there's a lot more cases than what I originally had. But we'll have to use the data that I downloaded. So the way the data shows up is there's setting name, which is where the outbreak is, and then the address for that particular outbreak, and then the city. It's broken down by city. Then we have total confirmed staff, total symptomatic staff, and then I included this type. So what I was interested in is that I wanted to look at whether or not for particular types of outbreaks, are there more confirmed staff at those particular outbreaks? So are there more confirmed coronavirus, COVID-19 positive cases at settings maybe like at the grocery store compared to the office, for example? Okay, so that's what I was interested in. And so I looked at each of these settings and I sort of, so there may be sort of disagreements with what I did because I looked up the setting and then figured out which ones were, I sort of grouped them in types. And then I had to further, there were too few cases per type. So I had to like clump into larger groups. So what I did was I have this other category, then market, which I include market and like restaurants, and then manufacturer, which are like factories. So I had to look up these places. So these are all like manufacturer. This type is associated with more like distribution centers, what is it? Like where things are manufactured. So I put them all under manufacturer. And then market, I put in, so Domino's is in here because I didn't want to put in other. I thought it was more like food related. I want to make this like food related, but like Mission Food, Bristol Farms, Vaughn's, Walmart, these are all sort of like place markets. So I sort of clumped all these together. And then I have this other category, which originally was like office, but there's other places that are not offices. So like the Skid Row Community Refresh Spot, that's not an office. It's more like a community area where people can utilize resources. But, I sort of all clumped it together so that it would work for this course, right? But this recruitment training center is actually where the LAPD trains, I believe. And then this is an office. This is also definitely office. So I clumped these all together. So what I wanted to do is for my independent variable, use type. So like the groups that I created here would be these 3 different groups, so manufacturer, market, and other. And then my outcome measure was going to be total confirmed staff. So that's total COVID-19 positive staff. So these are laboratory confirmed staff. So in order to look at that, you press Analyze, Compare Means, and then One-Way ANOVA. Okay. So again, my dependent list. So what I wanted to see is there a difference in the total number? So I'm going to just push over the total number of confirmed staff. And then so my type is my factor. So that's my independent variable, right? And then, so we also have our post hocs. So I want to just do my post hocs, and I'm just going to check 2K. So again, the reason why we're doing post hocs is because there's 3 different groups, right? Like what I was showing in the data. There's manufacturer, market, or other. And so what happens is if my F value, so we're looking at One-Way ANOVA, if it comes out as significant, then how do we know which group is significantly different from the other? We don't know, right? So we had to do post hoc tests to do the comparison between the different groups. And I'm going to just set my significance level. I'm just going to keep it the same at 0.05. Oh, okay. Oops. Okay, so now I'm going to press OK. My data should show up. Okay, sorry. I'm very impatient. So as you can see, we talked about this during class. We get our between groups. So again, we have 3 different groups, right? Our degrees of freedom is then for between groups is number of groups minus 1. So that's 2. So that's right. And then we have our within groups degrees of freedom, which is number of participants minus the number of groups. So I wish I could see how many cases. 6, 7, so 10, 17 minus 3, yes. So we had 17 different outbreak areas. And so that the within groups degrees of freedom is the number of cases we had minus, or outbreak areas minus the number of groups, which is 3. So that would be 14. And so then you add up the degrees of freedom to get total degrees of freedom. And then if we look over here, it calculates our F value, right? And our F value actually, so if you remember, if our F value is closer to 1, that means, on 1 or less, right? That means the amount of variation between groups is the same as the amount of variation within groups. So there's no variation, right? So it would be equal to 1. So there's no extra variation due to the group assignment, due to being in one of the groups. So as you can see, our F value is less than 1. And then when it's greater than 1 or much larger than 1, that means that there's a lot of variation due to groups. And then our significant value is non-significant. It's 0.42. And we can further see this if we go down to our 2K post hoc test. And you can tell that there's no significant. So it's comparing, right here it's comparing other, so the other group, to manufacturer and market, and then it's comparing the manufacturer group to other and market, and the market group to other manufacturer, and you can see that there are no differences between those 3 groups. They're essentially all the same. And so what that shows us is that for each of these types, there's no significant difference for what type of outbreak is associated with a higher number of staff. So pretty much we cannot reject our null hypothesis that there is no change between these groups in regards to how many positive COVID-19 staff they have at their outbreak.